Hi everyone, welcome back to the channel. My name is Priyansh Agarwal, and in this video, let me tell you about my course called TLE Eliminators that I've been running from April 2021. So it's been 3 years since I've been running that course. We have taught more than 5,500 programmers through that course already. Now this entire course, is divided into 4 levels. So for somebody who is at a particular level in their competitive programming journey, they can choose to join a level and learn only those relevant topics. So first of all, you get live classes on all of these topics, right? Every single week, we have around 1 to 2 live theory classes, and we teach you all of these topics in a very structured manner. Secondly, we provide you with curated practice problems on all of these topics that we've taught you. For example, if I teach you dynamic programming for maybe 3 weeks, then in these 3 weeks, I am going to give you 2 to 3 problems every single day. Now, in case you're stuck on any practice problem from the course, you get dedicated video solution where we talk about the exact intuition involved. How do you think? Apart from this, if you're stuck on any practice problem from or outside the course, we provide you with instant doubt support. Now, what happens in doubt support is that we have a team of around 30 to 40 experienced competitive programming mentors. These mentors are already experts and candidate masters on Codeforces, and they help you solve these problems in which you're stuck. Like you could come up with a debugging problem, you could come up with a problem in which you require some hints, and overall, you get to learn a lot from the experience of these mentors. And apart from that, there are other pretty cool features. You can go and check out our website to explore them. One thing that I want to mention is that TLE Eliminators is a live course, right? So every 3 months we launch one single batch, and in one single batch we run all of these level 1, 2, 3, 4 parallelly. So you can go onto our website and check out when is the next course coming up, and if you're interested, you can sign up for that.
Okay, so this is the first problem of today's Div 3 contest. And in this problem, we're given that we have 3 integers. Okay, yes, Div 4, not Div 3. Sorry. So in this problem, we are given that there are 3 digits, A, B, C, and we need to determine whether they form a stair, peak, or neither. So they have provided us the definition of what a stair is and what a peak is. So a stair is basically if the 3 numbers are like arranged, like the order in which we are given the 3 numbers, they are given in increasing order. So A is less than B and B is less than C, and a peak is nothing but that the middle number is more than the remaining 2. So this is a very simple implementation problem, and I don't think anybody would be having any doubt in this. So just take the 3 numbers and compare accordingly. If B is more than A and C, print stair. If B is more than A, and no, if B is more than both the A and C, then print peak. Otherwise, if B is more than A and C is more than B, then print stair. Otherwise, if none of these cases are true, print none. Is it clear? So nobody would be having any doubt in this, right? Yes, no? So let's go to the next problem. So in the next problem, we're given that there is an integer n and we need to print a 2n cross 2n checkboard, which is made of 2 into 2 squares alternating this hash and a dot. So this is basically, if it's 1, we need to print this. If it's 2, we need to print this. If it's 3, we need to print this. So now to solve this, there are many ways. Like how wide did this was? Give me a second. So we need to print something like, and then dots, then hash, right? And below this will be the same thing. And then we need to alternate, like, and this will continue. So if we see, if we are able to generate this string, let's say this, like these two can be considered as string, and using these two strings, we can get the complete answer. So how to get this string? just first, like you just need, these are n blocks, right? If n is 3, just create a string s as this, string t as this, basically reverse of this. So these are the 3 blocks in string t. Then just fluctuate between string s and string t. First print string s twice, then print string s t twice, then print string s twice. Please don't annote. Like, I'm not going to say this again. And whoever has done this, kindly remove this. So like, I'll stop that annotation also. Like, I don't like, if you are like experimenting, it's okay. But like from, okay, let's leave it. So we just need to print string s twice, string t twice, and string s again, like this way. If it was this, like we just have created string s and t like this. So this is one of the ways. I'm not saying that this is the easiest way, but this is, yes, this is one of the ways. There might be some other way also possible that which might be easier than this. And even having any doubt in this, basically create two string, and both are like, instead of like fluctuating after each character, fluctuate after two characters. Like this, which like once I show you the implementation, it will be basically this thing. So like this is the template, right? This is not, this has nothing to do with the code. So first I have taken n as input, then these are the strings a and b, and I'm creating, this is my, like, while explaining I said string s and t, here I have taken those as a and b. So this is my string a, this is basically a ternary operation. So what does this mean? That if I mod 2 is true, basically this is giving me true or false. If this is true, this is replaced in place of this complete thing. And if this is turns out to be false, this complete thing is replaced with just this thing. So if I mod 2, which is basically if I is odd, I'll get this thing. And if I is even, I'll get this thing. So we can see that for 1, we'll get these two. For 2, we'll get these two. And opposite of that will be getting added to B. Finally, by the way, I could have done the same thing here also. Like this ternary, and then this C out condition, otherwise the other C out condition. And but here I opted to do it like this, that simply goes from 1 to n. If I is odd, print A twice, otherwise print B twice. So why I'm explaining this thing in depth? Because see, this is the whole point of Dev 4. You can learn new things. So this is like this is just something that you can use in place of if. Okay, why did I start from 1 and not from 0? It's just like it better suited me here. If I would have started from 0, then either I need to have something like equals to 0 here, like if I need to keep these two same, or otherwise I would have to swap these two. So this like gives me a better picture, like what is being added. Like first I'm getting priority to this in A, and in B I'm giving priority to this. So basically to have a better mind picture, nothing else. That's why I'm starting from 1. Otherwise, usually I also start from 0 only. Is it clear? Anything else? Okay, so let's go to the next problem. So in this problem, we're given that there's a 24-hour format and we need to print it in 12-hour format. So, okay, so this is also a simple implementation problem. Okay, somebody had a doubt that we could have concatenated like how you cannot put in between, like you don't know the positions of backslash, and backslash and is basically the next line character. The next line character will not come between these. These are just part of string A and string B. Like this is a row. Backslash n will come here only. So you cannot concatenate it at these places. Hopefully this makes sense. And let's go back to this. So we are given a 24-hour format time and we need to convert it into we need to convert it into 12-hour format. So still there is some doubt. Someone said that backslash n is an end line, but it's written as a string. Backslash n is basically a character. Like it denotes that if I print this, it doesn't matter if I'm printing it as a character or a string, it will give me a next line only. Is it making sense? Like when your compiler is going through it, like when it encounters this, it automatically means that the cursor will go to the next line. So doesn't, like if I print this like this thing, it would mean that this is string and then the cursor will go to the next line. And this GB will get printed to the next line. So backslash n is basically, you can consider it as a character only. Like the compiler doesn't care whether it is F, G, B or backslash n. F means it will print F, G means it will print G, B means it will print B, backslash n means it will go to the next line. The cursor will go to the next line. So like this. And backslash T means that there would be a space of 5 characters. So like this. I think Apple or Windows, there's a backslash R backslash and also, so backslash R backslash and means that the cursor will go to the next line and shift to the first place. But those are like, you don't have to worry about those things. But yes, backslash n simply means go to the next line. And it is a character only. Like if you have it in a string, doesn't matter. So this thing, we have a 24-hour like this. So first of all, whatever we have here, minutes, will remain unchanged. And this thing, using this, we have to decide whether it is AM or PM. If anything less than 12 will be printed as it is along with AM. And if we have anything more than 12, we need to print anything more than or equals to 12, we need to print PM. But if it is strictly more than 12, then instead of printing 13, we'll print 1, 14 means 2, like this, right? So how do we do this? So this is also a simple implementation problem. How I have done this, I'm not doing anything with the minutes part. I'm just getting this in form of a number, like just getting a number so that I can have these comparisons. Once I'm done with these comparisons, I know whether it's AM or PM, and I'm calculating this particular time, like what do I have to print in place of hours. And once I have that number, let's say it's 7, I'm converting it back to the string. Why? Because I know I don't have to print 7, I need to print 07. So if my hours is having just one digit, I have added one more digit at front of it, like which is 0, and I'm printing 07. Minutes remain unchanged. So this thing will be coming as same, like whatever is minute, and I've already decided whether it's AM or it's PM. Is it clear? So I'm just manipulated this part. So let me show you the implementation. So this is a string is hours is calculated as, see, this is the first character s of 0. I'm subtracting 0 from it, 0th character. Why? Because the sky value, like this is the digit, right? If I subtract, if this would have been 1, like this would be character 1, I would subtract character 0 from it, not 0. Why? Both have different ASCII values. So I'm subtracting the 0th character, I'll get the this digit which is present at this position or this index, 0th index, I'm multiplying it by 10. Why? Because this is, if I have let's say 11 as the R, or I have 17 as the R, so this is the 1 of 17. So 1 into 10 plus 7, so 17. If I have 11, so 1 into 10 plus 1. Now this is my check whether it is AM or PM. Now if H is more than 12, I'm subtracting this, and I'm making sure that my F is 1. Why? Because it is PM. And I'm doing this also. If H is 0, I need to make it 12. Why? Because let's say the time was 12:30. I cannot print, like, I won't say that this is 0:30 PM. This is wrong, right? I need to print 12:30 PM. So if I'm getting 0 in place of hours, I need to make sure that it is converted to 12. Same thing for the AM. So if it is 0, just make it 12, convert it back to string, check if the size is 1, add 0 in front of it. If my flag is 1, print the hours. Then what is this? This is not a colon. Like these dots, and then print this is the minutes, the third digit and the fourth digit in the string, then print PM. Otherwise, do the same thing but print AM. Okay, ASCII is basically each character, like every character has a ASCII value. So your characters from, let's say, A to Z have ASCII values from, I don't remember completely, but I think it's from 97 to 122. Like if it is 98, it means small b. And same thing is for capital. I think it's from 65 to 90. And so these are the ASCII values, 0 to 9. Like these characters also have a value. So what I'm doing, if S of, let's say S, my string was, like this is the input that I get. So this character is my, like if I do S of 0, I'll get this character 1. So if I need to find what does the R, what I'll do, I'll subtract 0 from this. This will give me the difference 1. I'll multiply this with 10, and in this I'll add this 7th, which is this 7th character minus 0 again. This 7th. So I'll add these two parts and I'll get 17. So this is what I've done. Is it clear? Anyone having any doubts? Okay, so let's go to the next problem. So in this problem, we're given that a binary decimal is a positive integer whose digits are either 0 or 1. So then we are given, like we are given t test cases, and for each test case, we need to find, like for each test case, we're given an integer n, and we need to check whether that n can be represented as a product of binary decimals or not. So if it can, then we need to print yes, otherwise no. So let me explain this problem a little. See, binary decimals are like all the numbers, these are not, by the way, binary numbers. These are decimal. This is 101, this is 11, this is 1110, this is 1010. So these numbers are binary decimals. So anything that can be formed using a product of these is considered to be a valid, like we need to print yes for that. And if a number cannot be represented using a product of these, we need to print no. So the only, like, again, this is the implementation problem. There might be many ways to solve this. There might be an observation also that you can use to solve this problem. But what I have done, I've just brute force Why? Because once I got through the problem statement, I saw the time complexity. It is 3 seconds, and I saw that in the constraints it's given that n will be less than or equals to 10 to the power 5. Now, as soon as I got through this, I knew that I could do brute force. Why? Because first of all, how many numbers, how many binary decimal numbers are there between 1 and 10 to the power 5? So see, the number can be at max having how many digits? It can have at max, I won't say 6 digits, it will have at max 5 digits, because there's only one number which is having 6 digits, that is 10 to the power 5 itself. So the number can be like, you can replace this with 1 or 0, replace this with 1 or 0, 1 or 0, 1 or 0, 1 or 0. You can choose, like here you have two options, like choose any of these. Here again you have two options, here again you have two options, and two options, right? Yes, no? Like these are the basically different number of binary decimal numbers between 1 and 10 to the power 5. So simply 2 to the power 5 is the number of decimal numbers between 1 and 10 to the power 5. From this you can subtract 1, because there's also in this, there is one option that you'll select 0 here, 0, 0, 0, 0. So that is 0. You don't have to consider 0 as a binary decimal number, because if you multiply any of these with 0, eventually you'll get 0, and you are not checking for 0. The number n that you'll get in input is more than or equal to 1. So there are total 31 numbers between 1 and 10 to the power 5 that are binary decimals. So what we can do, we can check. Let's say we have an array, and let's call this as possible. So my possible of any value x is 1 if x can be created using product of can be created by multiplying binary decimals, and otherwise if possible of x is 0, then this thing cannot be like that. Then if x can't, so rest is same. So this is my possible array. So first of all, tell me possible. Let's say this is the first and second, third, all the way up till 10 to the power 5. Okay. Now, first of all, tell me what. Where is it? Okay. Now tell me one thing. What will be possible of 1? Possible of 1 will be 1 or 0. Like according to you, possible of 1 is 1 or 0. It is 1, right? Basically, if you just take this number, which is binary decimal, and nothing else, you'll get this 1. So it is possible to achieve this one using some binary decimals. So now what we will do, we'll just iterate from this 1, and we'll iterate through this 1, then 2, then 3. And if we see that possible, like let's say we are iterating through I, if we just will check if it's possible of I, then initially we know that there are just 31 of these numbers, right? There are just 31 of these numbers. So what we can do, if let's say possible of I is 1, that means it's possible to get I, then in this I can try and multiply all of these different 31 numbers, like all of these 31 numbers, and I can get I have 31 new numbers. So if that new number, let's say that is x, if that x is less than 10 to the power 5, less than or equal to 10 to the power 5, I can mark them here. That yes, this number is also there, this number is also there, this number is also there. When my I will reach here, then I can again try multiplying all those 31 numbers. So in worst case, my time complexity will never be more than 10 to the power 5 into 31. 31 is nothing but there are at max 31 different binary decimals between 1 and 10 to the power 5. Is it making sense? Yes, no? Like this is the only number, like different binary decimals between 1 and 10 to the power 5. So if it is possible to get, let's say I, you can multiply each one of these and get new numbers. Yes, the possible, like the size of this possible array will be 10 to the power 5. Is it clear up till now? Or there are any other doubts?
Is it fine if I unmute myself? Is
Yes,
I
yes.
always, yeah, is I always a binary decimal, the possibility of I, like you said, I into 31, right? Is I always a binary decimal? In the question, it was said both the numbers should be binary decimals, right?
So I, I is not a binary decimal. I is a product of like possible of I simply means that it is possible to achieve I using
Right.
multiplying some numbers.
Yeah, if possible of I means whether it is possible to achieve this number using two binary decimals. Like
Not two,
why are
not two. Maybe like here I meant that I have, maybe it is because of two. But when I come to this point, I again multiply, since possible of I is one, I'll again multiply this with all the binary decimal numbers between 1 and 31. So I'll get these also once. Then my I will reach here. I'll again do the same thing. So it's not just two. I'm not multiplying just two. I'm multiplying the existing possible number with a binary decimal number. The existing number which can be achieved using a product of binary decimal numbers.
do you have concise proof for this? Like how is this holding true for us?
How will?
How is this holding true for us? Like it's kind of looking like BP, like derived from some pre-computation.
Yes,
Uh,
this is basically DP only. Like what we are doing, like initially we just know that this is true. And we know that there are 31 numbers, 31 unique numbers, which are between 1 and 31, which are binary decimals. These are binary decimals. So what I'm
yeah.
doing, if this number is, like I can get this number. So in this number, I'll multiply all my binary decimals and I'll get new numbers. So here, like these are the new numbers. In this, when I come to this point, I'll again multiply all the possible binary numbers and I'll get new numbers. Maybe I'll get this again and I'll get this again. And I'll get
So
new numbers.
what you are saying is you're only multiplying if it was possible for me to build that number using a binary decimal, right?
Yes.
Because your I should be built from binary decimals to be for it to be multiplied with binary decimals.
Yes, this is already a product, like this is achievable. And in this,
Right.
if I come, like my I is this, then I'll multiply all these again in this.
This is fine. So, like, what I was thinking when you wrote this array was, if like it is a pretty very intense group. Like, if I had any number x,
Yes.
what if I tried all combinations? If I had 31 numbers, I
Okay.
could do a 31 cross 31 across all those binary decimals, right? If I had generated them
No,
into,
no,
if I,
you don't have to, like, if there is, let's say, x, you just have to multiply 31. There are just 31 options with this. So there will never be 31 into, like, why 31 into 31? It is just 10 to the power 5 times 31.
yeah, this is with respect to this question, like this approach. What I was suggesting was like if whether I could have done, whether I could have built the solution like that, if my possibility of x was there, right? If I wanted to build my x,
Then you will get TLE if you try and, like,
uh, because
my
I have 31 numbers with me, right?
you have 31 numbers. Yes.
Yeah. So 31 numbers, if I want to enumerate, like not enumerate, try out all possibilities. Like 31 numbers have 31 different possibilities for them. Like each number has 31
No, no,
different
no, no.
possibilities.
It's like if you have 31 numbers and like either you can select just one number, or you can select any two numbers and then multiply, or you can select any three numbers and multiply, or you can select any four numbers and multiply. Selecting just one number is NC1. Selecting two numbers is NC2. You don't have to order these, but 31C3, 31C4. After a point, let's say, like there will be some cases in this in which, like, if you choose four numbers and multiply those, they like the product will be more than 10 to the power 5. So you can disregard, but still, like doing it like this will give you TLE. Like I think 31C3 is also very big. I think 31C5 will be more than 10 to the power 9. I'm not sure, but
Like what I was thinking when I was solving, like when you suggested like a brooding, like there are 5 digits possible, and if I have 31 possibilities, right, for my binary decimal, like what is to get to my x, like any number x, I need two binary decimals, right?
no, you don't need two binary. You can need five also.
Can be five. They are not just set to binary. So I misread the question.
Okay, okay.
So it could be many binary decimals which
Yes,
are giving
it
me.
just needs to be a product of some
Okay.
number of binary decimals, not two. Okay. Any other doubt?
Hello, sir. How can we optimize this approach if, like, what if the n given was is less than 3 seconds?
Like first of all, the solution works in 200 milliseconds. Like my solution works in 200 milliseconds without fast input output. Now, if n is, let's say, if the constraints are, let's say, time is not like a governing factor here, but let's say n is increased. Like the numbers are going up till 10 to the power 9 or anything like 10 to the power 18 maybe. So in that case, this problem would become difficult. So like first of all, we'd have to come up with an observation, and then like I'm not sure like this how would we solve this for 10 to the power 18, but yeah, 10 to the power 9 can be solved, but right now I don't think like there's a point in discussing that. Like if you want, we can discuss that after the contest. But that
Felt
problem
like
will be a little bit difficult, not in like range of, I wouldn't say it would be like anywhere around 1500.
felt like bit masking and using a pre-computed array to uh, thinking about in terms of bits, maybe.
For what?
Like I felt like using a mask, and then like for every position, having some observation, like for every position, how much maximum number of bits can be set, right?
Bit.
So like uh, I was thinking of like normal multiplication of two numbers, because if I enumerate them into binary numbers only, like because they are binary decimals, so whenever I multiply two binary decimals, the first position and the last position should be set to 1 or 0. Right? Like it is purely based on observation. Then in the middle, I have to make some checks whether that particular decimal numbers could be achievable or not using some masks and maybe some method. So, yeah.
Like, did you try coding this? Like, did you try to code this down?
So, like I was trying, like I thought I didn't treat it as a simple problem. Like I treated it as a bit masking problem, so I couldn't come up with a clear-minded approach.
Okay, so like let's discuss this. Like, we can take this up after the
Yeah,
session. So let me show you the implementation. And by the way, it's like, how can we get all the 31 numbers? Like I said that we have 31 numbers. How to get those?
power set or maybe brooding with the request.
Using that also, but there is another thing. We can again brute force. Like the numbers are between 1 and 10 to the power 5. So just go from between 1 and 10 to the power 5 and just check whether the digits are only 0 and 1 or not.
That's all.
So let me show you the solution. So this is the implementation. This vector bin is basically the numbers that are binary decimal. So I'm going from 2 to 10 to the power 5. I'm not inserting 1 because I already know that it's a binary decimal. So I'm like, how to check whether each digit is between 0 and 1? If each digit is either 0 or 1. There are many ways to do this. Either you can iterate through over the digits, but what I have done, I have converted it to string, and I'm checking what is the maximum character in string. If it is less than or equals to 1, it means that the integer I is a binary decimal. So insert it in this vector. Once I have this, I'm creating Okay, sorry, I got disconnected. I'll reshare my screen. Yes. So like I was saying, that possibility will mark that this number is also possible. Then finally, once I have that whether between 1 and 10 to the power 5, which number is like possible for me to generate by multiplying these binary decimals or not, what I can do, I can just simply go through the test cases, take the n as input, check if it is possible. If yes, print yes, otherwise no. Is it clear? Yes, no? Like in this, the first part is just to find what all numbers can be created using product of binary decimals. So in order to get those, first I need what all binary decimals are there between 1 and 10 to the power 5. So that is this part. Just go from 1 and 2 to 10 to the 2 to 10 to the power 5 and just check whether the digits in this is between 0 and 1, like are 0 and 1. If that is true, like the digits are either 0 or 1, insert the number in your bin vector. Then let's say initially only this number is possible. So iterate from 1 to 10 to the power 5. If the ith number is possible, like you can get the ith number. If the ith number is possible, that you can get it using product of some numbers of binary decimals. In that number, you can multiply every binary possible number to get a new possible product. And finally, you just need to check Is it clear now? Yes, no, anything.
What would be the rating of this problem?
Like, I'm not sure. Like, this is a division 4, so I don't know.
But it is DP, right? Or like you could say some other
Like,
related.
like I don't think only DP. Like, maybe there can be an observation also in this problem.
Yeah, yeah.
And like, this is like I don't like this can be the intended solution, but like I actually didn't think anything about this one. I just read the problem statement. I saw that the constraints are less, and I just implemented it. Maybe if I would have given it a thought, I would have also came up with an observation. But since the problem constraints are low, so I just applied brute force. Time complexity of this code will be like how many operations? Speaking it, like just speaking it by looking at the n, it would be big O of n. But looking at the number of operations, it will be close to n into 31. So still, like not more than 10 to the power 7 operations. Okay, so let's go to the next problem. So we are given in this problem, we're given that there is a string S of length n consisting of lowercase Latin letters, and we need to find that what is the shortest string k such that several copies of k can be concatenated together to form a string of same length as S, and at most one different character. That means there is at max one different character in S and the string that we have created by concatenating k copies, like some copies of string k. So let me explain this here. So we have a string S, let's say, and we need to find the smallest string let's say k, which can be repeated some number of times, and let's say this string was a b c a b c a b c. So in this case we can get k as abc, and this is the smallest string that we can repeat to get the original string s, and it is like there is no place where the characters are different. But let's say in place of b we had d here, so then also we can choose this k. Why? Because there's after the string that we'll get after concatenation will be something like abc 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 abc. Only this character is not same as this character, so it is also correct that like only one character is different. So this is what we have to find. So again, like first of all, is the problem statement clear? Okay, so again, let's go back to the problem And in this, we are given that n is less than 2 into 10 to the power 5. So again, like we can apply brute force. How? If probably you guys, I don't think whether you know or not, if there is a number n, the maximum number of divisors, total like the maximum number of divisors n can have is at max 1 by 3. This is the upper bound for the number of divisors a number can have. They can be at max cube root of n, number of divisors for n. Like it will be either less or at max equals to this, like this is the upper bound. So tell me one thing, if let's say the string is of size n, the string k, if like string s is of size n, string k will be of size x, n should be divisible by x. Is this making sense? This should be true. Yes, no. So how many different string k are there possible? Let's say this is string s. There are at max, like either string k will be this or this, like all of these are divisors. Total number of possibilities for string k is n by n to the power 1 by 3, cube root of n. Like if n is not divisible by x, your k is of size x, then how will it, like upon concatenating, will give you exact string? And since x needs to divide n, that is the size of string k needs to divide the size of string s, there are at max cube root of n possibilities for string k. Like it will start here only, like either it will be these characters or these characters, or maybe like if this is also a divisor, like this much length, then k can be this also. But like there are only these many possibilities. Is it making sense? Yes, no? What about others? So now can someone tell me what is a cube root of 2 into 10 to the power 5? What is the cube root of this? It is close to 58 or 59. So even if you take 60, let's say there are 60 possibilities, and each possibility you're checking it for the complete string, whether or not you can get a string is, you'll get this much complexity, 60 into n. Again, this is 60 into 2 into 10 to the power 5. How much is this? So these operations can also fit in 1 second. You don't have to do wrap and cap, you don't have to do anything, you just need to check character by character. Let's say this is the string that you're checking. This is the string that you're checking. So you just need to check whether this character is same as this character, this character is same as this character, this character is same as this character. Again, check for this character, and this character. Like this. If you identify two positions, yes, it's basically a sliding window. If you identify two positions that the characters didn't match, then basically this cannot be string k. This is not k. Right? But there is one more thing. It's possible that maybe this is not string k. This can be string k. Why? In case of, you can, this is not string k, but this is string k. Like if you repeat this, you get hs, 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 hs. So basically you just don't need to check for the first size k substring, you need to check for second also. And why don't you need to check for third? Because if the first one is not possible, the second one is not possible, it basically means that there would, like, no other string can satisfy both of these. So there is at least two characters different. Otherwise, one of these would have been the answer. You can also check first and last. Like just don't check for the first alone. Check for any other substring of size k. Like, and not any other, like you cannot check any random. Like it should be either the first k the second k length, the third k length, or the fourth k length, like this, one of these. And how do you need to check? You can just check, compare character by character. The size of string is at max n. We already know that the total number of possibilities is n to the power 1 by 3. So the total quantile complexity is n multiplied by 4 by 3. Is it making sense? Yes, no. Like this is also a brute force only, by the way. Okay. Any doubts in this? Okay, so let me show you the implementation. So in this, like this, I have just pre-computed, like on the runtime, I don't want to calculate the divisors for any number. So this is the sieve method. Like using sieve, I have pre-calculated that what are the divisors for every number. So how I've done it, I'm going from 1 to 10 to the 2 into 10 to the power 5. My j is going from I to 2 into 10 to the power 5. And each time I'm incrementing my j with I. So basically j is a multiple of I. So if j is a multiple of I is a divisor of j. So this is a simple sieve method, sieve of parenthesis. Then for each test cases, if I have the divisors, I'm iterating through the divisors of n. Initially my count is 0. This is me like considering the first e length substring as the possible string k. So how do I do that? Like I'm going from e, like why e not e plus 1? Because my index starts from 0. So from 0 to e minus 1 is the first e length substring. Then I'm iterating from e to n, and I'm simply checking if s of I is not equals to s of I modulo e. What does this mean? I modulo e. This is the character in the first e length. Like if let's say I is 10, e is 3. So 10 modulo 3 will give you 2. Will it give 2? No, it will give 1. So 1 means the second character. So the 10th character should be matched with this, like the character which is at the 10th index should be matched with the character which is at the first index. So this way we check if count is more than 2, then this is not true. If count is less than equals to 1, I can simply print this is my E. Why? This is one of the, so like because I will be iterating in increasing order, because that is the order in which I have inserted my divisors. So this is my answer, and I will simply break my loop. Otherwise, I'll again make my count 0, and now I'm checking for like whether k is, like k can be my second substring of like size k. If the string which is starting from eth character and is going up till 2e minus 1. So basically this is, I'm checking for the characters after 2e, and this is, I'm checking the characters from like 0 to e with characters e to 2e minus 1. Like in second time I'm considering, like let's say e is my this length, this is from e to 2e minus 1. So this is from 2e to n minus 1, and this is from 1 to e minus 1. So I have checked this and I have checked this. So I'm checking these characters one by one. So this is that thing. So like if the character here was I modulo e, it will be e plus I modulo e here. I know like this is too much number theory if you have just started with CP. And I have a really bad habit of like unnecessarily inserting maths in problems that don't require it. Finally, I can check here also that if count is less than 1, less than or equals to 1, simply print E, otherwise break. And by the way, I'm simply breaking the loop here and I'm not printing anything outside this loop. So can anyone tell me like why I'm not printing anything outside loop? Like it might be possible that the answer is not possible inside this loop. Like I'm not able to get the answer. So why I'm not printing anything outside the loop?
Because the length is always the possibility the entire length.
Yes, yes. The like sorry, I was muted. Like n is always a divisor of n. So 5 will always divide 5. So one of the divisors of n is n. And then when I check for n, this count will be 0 only, like all the characters match. So in that case, I will simply print the answer here. So that's why I'm not printing anything outside this loop. Is it clear?
Can you please let us know on what conditions you're sliding the window? Like, can you show it on the pad?
Yes, yes, yes. What? What do you want?
On like what conditions exactly have to be satisfied when you're sliding the window of size k, let's say, of the divisor k?
Yes, let's say the divisor is E. So if I'm checking with like whether or not this can be my k the string or not. So I'm checking it with first this, then with this, then with this. And how I'm checking it? That this character should be matched with this, this with this with this. Then this character should be matched with this thing. This should be matched with this, and like this. This should be matched with this.
Oh, okay. So you kind of you use a bit of math to play around with the indices, right?
Like you're not clearly audible.
Hello, am I audible?
Yes.
Wait a second.
Is it clear?
Hello, am I audible?
Yes. Yes, yes.
Like, how exactly? Like, I got how we are sliding the window and how we are checking up. We will be sharing this flow. I'll come to the recorded version of this thing to understand your code a bit. Like, for the
Yes, yes,
indices,
I'll share all the codes. Like you'll get the codes plus recording.
yeah, it's fine.
Anything else? Okay, so let's go to the next problem. So in this problem, we are given that we need to find the minimum height of a rooted tree with a plus b plus c vertices that satisfy the following condition. A is the number of vertices that have two children, B is the number of vertices that have exactly one child, and C is the number of vertices that have exactly zero child. So basically, we need to find what is the minimum height possible if A is having two child, like A number of nodes having two children, B number of nodes having exactly one child, and C number of nodes are basically having zero child. So these are leaf nodes. So if you know, first of all, like this is just like how can you arrange the nodes? So if there are A nodes which are having two child, like this is the property of a tree that the number of leaf nodes will always be equal to like does anyone know what is this number? 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 What should I write here? A plus 1. So leaf nodes is always equals to the number of nodes which are having 2 child plus 1. Why? Like this is quite intuitive. See, first of all, if there is a node which is having 2 child, this is one node, it will have 2 children. Now, if there is another node which is having 2 child, let's say this is the node, it is already like at this point, it is not adding, like at this point, it was one node, this is having 2 childs and this is having 0 child and 2 node. After this point, you'll just keep adding 1 on both sides. Like how? So the number of leaf nodes got subtracted by 1 because of this, because it has now 2 children. So minus 1, and you added 2 leaf nodes, so plus 1. Net is plus 1. And there is, because since this is having 2 childs, you added 1 node. So if you keep adding nodes with 2 childs in this tree, you'll see that in each step you're just adding 1 on both sides. So eventually the sum of this A will be like plus 1 more than sum of this. So C should be A plus 1 should be equals to the number of leaf nodes, that is equals to C. Like this is intuitive only. And probably this would be like you'll get this once probably like you cover the trees part. So the number of like nodes which are having 2 child is always equals to like C minus 1. That is the number of leaf nodes minus 1. So leaf nodes is always equals to the number of nodes which are having 2 child plus 1. So if this is not true, the tree is not possible. So in that case, simply print minus 1. That is the tree is not possible. Otherwise, you need to find the minimum height. Now, how to find the minimum height? C. First of all, C is the number of leaf nodes. So let's try to arrange all the leaf nodes like this, like in a complete tree, in a complete binary tree. If let's say there was a complete binary tree, what is the height of this tree? So height of this tree will be log 2 number of leaf nodes. Yes, no. Basically at each step there are a multiple of 2 nodes, like more like here there are 1 node, 2 node, 4 nodes, 8 nodes. So like this, the height will be log 2c. Like if it is 8 here, so log of 2, like the height is 3. So this will give us that, okay, this much. Now we can accordingly, like let's say if we have less number of what? Less number of 2 nodes, like the nodes which are having 2 child. So what we can do? Like either we already know that A plus 1 is equals to C. We are trying to arrange, like, let's say A plus 1 is still equals to C, right? So we'll have less number of C. Like this, we have calculated like how many nodes can be arranged like this in such a way that like these are the leaf nodes and they're all at the same level. So for that, height will be log 2 of C. Now let's try to see that okay, this thing is clear. Okay, now there will be some nodes that are left. Basically, I had only these number of leaf nodes. I didn't had these. I added these extra. So like these are not the leaf nodes that I have. So these are technically these are not the nodes that are given to me in C. So what I can do in these extra nodes, I'll try to arrange the nodes which are B. Like here I cannot arrange B. Why? Here I cannot arrange B, but I can arrange B at these nodes, or this is also a leaf node. So what I can do, just remove this and arrange leaf nodes like this, because not leaf nodes, these nodes which are having B. Why? Because B number of nodes are nothing but they are just nodes which are having one child. So you can just replace any leaf node with a node which is B. So those nodes won't make any difference. What is 2 times h plus 1? Like height is like no, height is basically from root node. What is the farthest node? That is the height. Now we know that, okay, where was I? That, okay, these are the number of nodes, like B can be arranged anywhere. And after we have arranged B, let's say there are still, like we were able to arrange B in all of these places, but still B is left. Let's say three nodes of B are left. So those 3 nodes again we'll have to remove one by one. We'll have to increase these. So eventually everything will depend on what was like after C, what was like from C you calculated the height, initial height. From that you got what is the count, like how many nodes are in one row, like how many nodes are in this row, final row, and in that you have to arrange B nodes. So basically your height will, like how much your height will increase, your height will increase by B divided by what was your count of is this thing, the nodes in the last row. So count and C, and in this you'll add an initial height. Initial height is nothing but log 2 C. So from log 2 C you got this height, basically the part of this. From that you can get how many nodes are in the last level. From that you'll get, this is the count, the number of nodes in the last level, and try to arrange, like let's say there are some empty places, in that you'll arrange B, and B are the nodes which are having just one child. If there are more number of B nodes, this is how your height will increase. Like in each row, in each level, you'll try to fill it up with count nodes, and then you'll shift again down. So like this. Now this row is also filled, so go one level down. Is it clear? So simple. C log B divided by count. Like I know this is just like, if you don't know how trees, like how would you arrange these nodes, this may seem too much. And if you don't know this thing, first of all, like this, if you're seeing this for the first time, like you would have been confused at this point only. But believe me, once trees gets covered, like if it has been covered in a level, then like this would seem a really easy problem once you get down to like that intuition, like how you would arrange nodes in a tree to get the minimum height. Otherwise these things, like this won't make any sense to you at like current point. Yes, basically if the last half is not, like the last level is not completely filled, you'll first fill it with B nodes, like these nodes, B number of nodes. And after that also, if some nodes are left, then like B is, let's say the last level was can have count number of nodes, that is 10. And it is like, let's say it can have up to 16 and only 10 nodes are there. So 6 nodes, like 6 nodes can come from B, that is nodes which are having one child, but B is 8. So you are left with 2 nodes. So 2 nodes will go to the new level. So you need to divide 2 with 16 and take C. So this is basically 1. Your height will increase by 1. If let's say there were 17 nodes, then your height would have increased by 2. If let's say there were 15 nodes, 15 remaining nodes, you can take 16. So then your height would increase just by 1. So that's why C. Is it clear now? Okay. So this is the implementation. In this, I have first taken A, B, C as input. If A plus 1 is not equals to C, then simply print -1. The answer is not possible. Otherwise, calculate your initial height, log 2. And this is 2 times C minus 1. This is basically the total number of nodes. Like if the C is the nodes in the, like, I think I wrote like anyway, you can do it like this also. What I wrote here was, where is it? Yes, here. I wrote 8 number of nodes in the last. You can write it as log 2 8 plus 1, or you can, like, I know this is too much, but actually what, in a complete binary tree, if let's say there are x number of nodes here, inside these are called internal nodes. These are x minus 1. So total number of nodes is 2 times x minus 1. If you take log of this, you'll get height 1 indexed, and if you take just log of this, you'll get height 0 indexed. So if I want height 1 index, like starting from 1, by 1 index I mean the count of nodes. Like in this, the height is 3. If I'm taking the count of these nodes, if I'm taking the count of edges, then the height is 2. So basically here we have taken the count of nodes. So total number of nodes, 2 times c minus 1. C is the leaf nodes, that is the initial height. This is the total number of nodes that can come in the tree of height h. So like this is the total number of nodes that can come at the last level d. So from this we'll subtract c, whatever is the, like, the leaf nodes, and from that, like, now if the last level is not completely filled, we'll subtract, like d is the available number of positions. Those positions are being filled with b, and after that b can be still left something, and c is the number of nodes that are in the last level. So from that, like, this is the seal. How to take b by c seal. Finally, we can print the height. Like this is increase the height and just print h. So first, just calculate the initial height, fill the last level. If there are some more nodes in b, just take the seal division and print the height. So let's go to the next problem. So this is the last problem, and in this problem we are given that Vladislav has a playlist consisting of n songs, numbering from 1 to n. Song I has genre GI and writer WI, and he wants to make a playlist in such a way that every pair of adjacent songs either have the same genre or the same writer, and he calls such a playlist exciting. Now the thing is, the song and the genre are strings of length no more than 10 to the power 4, and it's always not possible to create like a greater exciting playlist with all the songs. So first of all, they, like, some songs will be selected, then they will be arranged in some order to get the exciting playlist. Now we need to find the maximum number of songs that can be chosen such that, okay, we need to find the minimum number of songs that have to be removed to get a exciting playlist. So let me explain this. See, there are n songs. Each song will have a genre G1, G2, G3, G4, G5, G6, and each song will have a writer. So if let's say this is the order, either these two needs to be same. Let's say these are same, these are same, this writer is same, this genre is same, this genre is same. And it can also be possible that the genre is also same and the writer is also same, but at least one should be same. So this is an interesting playlist. these two are same, these two are same, these are also same, these are also same, and finally these are also same. So, but this is not a good playlist if these are not same. So now how to do this? If we look at the problem constraints, n is between 1 and 16, and we are given that we need to choose, like so we need to check for every possibility. Like let's say when we chose, like let's say there are 16, 1 2 3 4 5 6 7 8, all the way up till 16. Let's say these are 16, so we need to choose which all songs we are first of all choosing, and then we need to rearrange. So this is a classical DP problem, DP bit masking problem. So we need to bit mask, like why bit mask? For choosing, and DP will give us like answer for every possible scenario. So what all we need in DP? We need two things. First of all, what is the selection? What is the mask or selection of songs? And the next thing is currently what is the last song that was selected? Because after this we'll add new song here. We need to check whether these two are compatible side by side. Like either they should have a common genre or a common writer. So this thing will tell us last selected song. After this point, it's really easy to solve this. So this is masking, like this will be a number between 1 and 2 to the power 16. And let's say this is anything x. So x will be something like 1 0 1 1 0 0 1 1 0 1. So this tells us that the first song, third, fourth, and seventh, eighth, and 10th song are selected. 1 represents that the song is selected, 0 represents that the song is not selected. So now let me like the transitions will be easier to explain here. See, first I'm taking like G and W are strings, string arrays, and I'm taking like what is the genre of ith song, what is the writer, who is the writer of the ith song. Then possible is basically whether it's possible for me to combine, like whether I can have jth song after ith song. So I can have jth song after ith song if either the genre is same or the writer is same. This is the or condition, by the way. So possible of ij means that I can combine, I can keep jth song after ith song. So initially my DP of ij is false, like everything is false. So ij means that from a selection of I, like this is the selection, this is the mask, and the last song is this. So initially this is everything is false. Then I'm marking DP of like when I only have just one song. I only have one song, let's say ith song. So in that case, the selection which is having just ith song. So basically the ith bit will be 1. This is the selection, and I'm marking this as, in my DP, I'm marking all of these as 1. So basically the selection, mask, and the ith song as true. Then this is my DP transitions. So I'm iterating through all the selections, all the songs. If this is the current selection and the last song was J, and this is possible, then I'm calculating the answer. How many bits are set in I? You don't need to use like built-in pop count. You can iterate through the bits of I, and you can check how many bits are set in I. And probably do this outside this loop, J, because no need to do this inside this loop. You can do it here also, but still the time complexity is same, because the governing thing is not this thing here, but this thing. So we are calculating the maximum of answer is maximum of answer, or how many bits are set in I, because we already know that it's possible for us to have this selection and the last selected song is this. Then we are iterating through all the songs. We are checking that if this song, this kth song, we are trying to include kth song in our current selection. If the kth song is already not selected, how to check that? That k should not be included in I, and it's possible to include kth song after j. What is possible of jk? It simply means that we can select kth song after j. So if kth song can be selected after j, and kth song is already not in our selection, mark this as also true. What is this? in the ith song, in the ith mask, I'm taking OR of this bit, like this kth bit. 1 left shift k is nothing but 2 to the power k. So mark this as also, like this is the selection. Last song selected now is k. Mark it as true. Finally, answer will be maximum of what? Like what is the maximum number of songs I could have selected? So n minus answer is the minimum number of songs that you need to remove. Is it clear? Like solution is really simple, believe me. If you know bit masking DP, the solution is really simple. Like this is the only transitions. This, no, not this, but only this thing. So anyway, hopefully like you would have learned something from this. And since this is a day 4, and I think like it was like there were many things that you could have learned from this contest, but don't get disheartened right now. Like just try to upsolve. Like right now you have seen like what is required in each problem. So give a try from your side. And thanks for joining. Bye bye.